Hey guys, welcome back to the shop. Today's project involves Canister Damascus, but not your typical Canister Damascus. Usually with this method, you're putting a bunch of stuff into a steel can like ball bearings, bits and pieces of previous pattern welded steel, what have you, and then filling in all the gaps with powdered steel typically. And then your blade is a pretty randomized piece, and your edge is on whatever steel it happens to be on in that whole project, that whole billet. Today I'm going to get a little more precise with the edge here. This is actually going to be a form of san mai, if you will, because the edge steel is going to be sandwiched by the rest of our can contents, and we can forge that out and make a good blade. So I need to get a length here and cut off some 50-100 steel. This is 3/4 round bar. This is my favorite blade steel, and it just works really well. I don't know what else to say. You'll see that later on in the video here. Need to get this rounded off here a little bit, cleaned up, make sure that it fits. I need a little bit of clearance there to put my other cap on there. And then I got to clean this rod up here to make sure that it forge welds to the rest of the contents. White paint, that keeps the contents of the can from welding to the can, makes removing it much easier. That's my favorite way to do it. I've tried to use the whiteout stuff. I've used stainless steel foil, but this way, it's the best way to do it. 3/16" ball bearings, and we're going to fill in the gaps with 1080 powdered steel that contains a 4% quantity of nickel powder as well. You need to make sure that that's vibrated down real well, which I actually use my Sawzall without a blade on it. That works real well to do that. Needs to be no air in there if at all possible. And we'll smash that lid down on there and get it welded up with a handle. You can see where I indexed where my blade, where my edge steel is, so that I forge this properly. Probably heated this up for 15 minutes, depending on the temperature of your forge. That's plenty adequate. You just need to make sure that the contents of that larger cross section are fully heated through before you try to forge weld it. So this is just going to be the actual forge welding process where we smash everything together using my V-shaped dies, and that puts the most contact onto that billet. So you can see the can is coming off pretty easily. And I have to pay attention here to how this billet comes out, because I need to know where my edge steel is. I actually had to take and put that back in the can the same way it came out to make sure I knew which side was my edge steel, because this process right here is going to be crucial. If I turn the billet the wrong way, we've ruined the whole thing. So I'm flattening it out, and obviously my edge steel is on one side of the narrow side there. Had to go back and forth a couple of times and grind out inclusions or cracks on the edges of the billet. This is pretty par for the course on ball bearing Canister Damascus. The reason for that is because as you compress that in the V-shaped dies, you're actually stretching the billet as well as compressing it widthwise. And since you're not starting with a solid piece of steel, as you're stretching that out, you know, the very edges don't have the opportunity to forge weld before there's linear tension placed on them. It's just a matter of grinding those out, and usually they're pretty shallow. Make sure that they're not in your final product. Not a big deal. So we've got this forged out to a thickness that allows me to leave plenty of material on, but I'm going to start with the tang, or the handle, first. And I cut off the end of my billet there, because the end is also a little cruddy. You've got inclusions on that. Just cut that off and at a nice angle there so I can forge out this cool Bowie knife handle. So what I'm doing here is I'm making a handle with an exaggerated flare, almost a pistol grip style, if you will. And what that's going to do is going to allow for a nice secure grip on this big chopping Bowie. Using the power hammer to stretch things out a little bit more here. I'm getting close to the finished dimensions, so I need to go ahead and forge in the point, or the tip, of this Bowie knife. Since we have to cut off the end of the billet anyway, this makes sense, and we'll just cut off at an angle there so we can go ahead and preform and stretch that edge steel around to the tip. This is one of the most common ways of forging the end or the tip of a knife anyway, and it works especially well because we only have one side where this edge steel is, and we need to pull that all the way around up to the tip. So far this project is going pretty well, and I'm pretty excited about how it's going to turn out. After this, I'll go ahead and forge in the bevels a little bit. Need to straighten things up along the spine and along the edge portion as well here. The only thing I'm worried about at this point is making sure that my edge steel is centered, because I'm not 100% sure where it's at. I'm pretty sure it's right there in the center, but I did have to do some grinding, and I with the angle grinder to get those cracks out, surface cracks out, and I tried to do that equally on both sides, but you just don't know for sure until you get into the billet, into the Bowie knife there, and do some grinding. So we're getting really close. Got the blade forged out nicely. I'm putting in a little bit of a distal taper here, flattening things out using the 50-pound Little Giant, and it's going pretty well. So the forging process creates a lot of internal stress in the steel and a lot of discontinuity, if you will. We need to get everything back to a more homogeneous state. The grain size needs to be the same across the steel. This is all important for setting ourselves up for a good, strong blade in the heat processes to follow. The next thing we got to do is go ahead and grind off all of this scale. And something I did off camera here is after I normalized it, I also did a process anneal on it. So basically a divorce eutectoid anneal, which simply means it's softer and somewhat spheroidized. The main reason for that is to put the carbon back into a better place inside and get it ready for another quick thermal cycle before we do the quench cycle. But also that allows us to grind this pretty easily and to drill the holes in the tang because it's relatively soft at this point. So I've got a lot of material here to take off, and I just need to make sure that my edge steel is mostly centered, is really close to being centered. So I was able to keep track of that. You can actually see it if you look closely, not in the video, but as you're grinding it, fresh ground steel, you can see the difference in the nickel content in the ball bearings and then the edge steel. So this is that steel after the process anneal, and this is actually the first time I've done it this way. And so this is a little bit of a test as well, because typically I do quite a number of thermal cycles, and this is another method that achieves the same results as far as I understand. And if I can do the same thing with less time and energy input, then that's a good thing. So we're able to drill our holes here without any trouble, which is a nice change there. I did a couple of thermal cycles in between before quenching, and here's the quench. This is a pretty heavy blade, so we got to make sure that the residual heat is out of there so we don't get any over auto tempering on this blade here. You can already see the pattern starting to come out a little bit. So it is time to temper this blade and remove a little bit of the hardness and gain some toughness. And this kiln here I actually purchased mainly for axes and hatchets, but it's actually been really nice to have a second kiln just in the aspect of making blades, because once you've quenched your blade, you're coming out of a hot kiln, 1475, 1500, whatever, and it takes a lot of time for that kiln to cool down. So what do you do with your knives in the meantime? So it's nice to have a second kiln ready to go for the temper cycle. This is our finish grinding process here. I'm going up to 220 grit, and these belts were giving me a little bit of trouble, leaving me some wavy lines on my bevels. And I think it's because the seam or the joint on the belt fills up and starts gouging out of the side of the blade. So that's kind of a bummer. But I was able to get it pretty decent. So I left probably 35 thousandths on the edge, and we're going to go ahead and go with a nice convex edge here. 35, 40 thousand, something like that. I'm actually using my slack belt attachment, which I also purchased for using on axes and hatchets primarily, but it works pretty well for this too. And that's just a much more controlled and safer way of using a slack belt instead of the top of the belt. So this is our chop test. Okay, it's twice through, so you can see where we've been doing all the work right there, trying to focus on the same spot. And you can see that on the blade there. Let's go ahead and check that. And it still shaves nicely. Oh yeah, let's keep going. All right, fourth time through. Still takes hair off. So I'm pretty happy with the results so far of this slightly different method of getting good results on this steel when it comes to the heat treating process. And I enjoy learning and trying to dial this in for my shop on this particular steel as close as I can. So a bunch of hand sanding there. Don't really show much of that. It's not really my favorite thing to do. Overall, I kind of find it to be an abrasive experience, but it's necessary if you're going to make a cool knife sometimes. So cleaning the oxides off of the etched blade, in and out of the ferric chloride multiple times until we get the desired result. Now it's time to put a handle on this thing. So I'm using some pretty hefty blocks of leopard wood here. The reason for that is because I want to put a nice flare or bell on the end of the handle for good grip retention. So we'll get this ground down and shaped up here, and that of course also involves some more hand sanding, but we're getting really close here. Alright guys, we're reaching the end of this epic Bowie knife build. I've got some nice Danish oil on the handle here, brings that luster out nicely. I'm going to show you some pictures of this whole beautiful knife in just a second. But before I do that, if you've enjoyed this video and you like what you see on the channel here, consider supporting it. It doesn't cost you anything to hit like, hit subscribe, leave a comment, and even hit that notifications bell so you actually see upcoming videos. If you want to go a step further, there's always Patreon. That's in the description below. And my website, check that out. I'm trying to put up product as quickly as I can, so bear with me on that. Get on my email list. That's on the front page of my website, so you know when new stuff is ready to go. As always, appreciate you guys watching, and we will see you on the next video.